are four main types of probability samples. The first, simple random sample. So let's take a look at how that works. So a simple random sample is a sample selected so that each individual in a population has the same chance of being selected. So this would be the equivalent of taking everyone from the population and putting their name into a box and shaking it up, and then we pull out a slip of paper, certain number of them, to create our sample. Okay, so everyone, because everyone from the population's name is in the box, then everyone has an equally likely chance of being selected. So if we put 20 names into the box, then each person has a 1 in 20 chance of being chosen to be in the sample. The example or simple random sampling that we see today is kind of the random digit dialing. So if we randomly generate phone numbers from a particular geographic area, then everyone who has a phone, so assuming the population of interest is someone who has a phone, then everyone has basically that same chance of being selected. Now, it means that you do need to make sure that as you pull from either from that list of all possible phone numbers or you pull from the names in the bucket, that it is being pulled so that everyone does have that equal probability. So an example of where this didn't work out is in December 1969, they attempted to use simple random sampling to determine who was going to be drafted to go into the Vietnam War in the US. So what they did is they put into a bucket all the birth dates. If you were, they would basically have, January 1st, January 2nd, January 3rd, January 4th, January 5th, right? All the different days, 365 days a year. They were all slips of paper that were dropped into the bowl. The thing is when they wrote up all of the different slips, they wrote them in chronological order. So they wrote January 1st and put it into the bowl, and January 2nd and put it into the bowl, and dropped them in. So the top of the bowl is the last days of the year. And then they didn't shake up the bowl. So when they go and pull out who is going to be drafted for the Vietnam War, most of the men who ended up being drafted were born in September, October, November, and December, because that's what got pulled when they pulled it out. So it wasn't truly a simple random sample. Everyone didn't have an equal probability of being selected. Not because there wasn't representation inside the bowl, but because they didn't mix up the bowl and they put it in chronological order. So then based on how it was pulled out from that sampling frame, so the bowl being your sampling frame there, then it wasn't an equally likely chance for everyone. To determine the probability of selection in a simple random sample, we would take the sample size and divide by the population size. So for example, if we want to have a sample of size 30, so let's do easy math, and that there were 100 people in the population of interest, then the probability of selection is 0.3 or 30%. That means everybody whose name is in the bowl, assuming the bowl is all randomly mixed up, is a 30% chance of being selected. So about 1 in 3 will be ending up in the sample. The idea with the simple random sample is it's easy to select a sample, and this method is going to be the method that has the least amount of sampling error. Because everyone has an equal non-zero chance of being selected, assuming we shake up the bowl, then it's going to have the least amount of sampling error. that is the sample statistic, whether we're looking at proportions or averages, whatever summary we use for the sample is going to be the closest to whatever we're using to summarize the population. Okay, so simple random sampling, we could have everyone's name in a hat or a bowl. We could also do random digit dialing, where we are randomly using a random number generator to randomly choose the digits to the phone numbers. And if we had 100 different possibilities for the phone numbers, then we would just randomly generate 30 times in order to have that probability of selection for, say, 30%. So we are going to need, in order to do simple random sampling, you do need to have the names or the phone numbers of everybody in your population. So it does require a list of all of the entities within that population of interest. So that's the limiting factor here, and why we often don't end up with simple random sampling, because we don't often have the names or the contact information for everybody in the population of interest. So simple random sampling is the best approach to get your sample to match the population. It's also the easiest, but it only works if you do have that list of everybody in the population. Another type of sampling method is called systematic sampling. And with systematic sampling, what we do is we have a random starting point that is selected from a population list. And members of the population are selected using a skip interval. All right, so let's suppose that you have 100 people in your population, and you want a sample size of 20, then we take 100 divided by 20 and we get 5. And so our skip interval would be that we would contact then every 5th person. So we would pick a random starting point in our list of our population, and we would then contact every 5th person on that list. Okay, this is less expensive than random sampling. The challenge we have is that we have more sampling error if there is some kind of underlying pattern to which the population is listed. So if the only reason, so let's say we take the phone book. If we took a phone book and we chose every 5th person in the phone book to contact, then we would have people right at the beginning of the alphabet, and we'd have people at the end of the alphabet, and so we would have a representative sample. However, if not everybody is in the phone book, right? So we talked about, now we don't have phone books, but back when people's phone numbers were listed in a phone book, and then more and more people had cell phones, people with cell phones didn't list their phone numbers in the phone book, people with landlines did. So if you were choosing from a phone book every 5th person, then the problem is that it excluded an entire group who didn't have their names in the phone book. We have a sampling frame problem. What if we have, say, a list of customers? If we have a list of customers or a list of employees and we contact every 5th one, we will get a representative sample as long as there's not some kind of underlying pattern in the list that would cause, okay, well, if you picked every fifth person, then you're excluding some kind of characteristic because those people are only listed every other time. So it's about sampling frame in terms of, does your list contain a representation of the population? And then if you're selecting every fifth person or 10th person, is that still capturing people at random? Because in the list, it's not, for example, that the first half of the list is the frequent purchasers and the back half of the list are the people who rarely buy from us. Well, then are we going to just get a small sample of people who purchase frequently from us and then end up with most of our sample being people who never buy or who very rarely buy from us? So if there's a big chunk, one characteristic here, and then another chunk, are those equal in size? So you're pulling the equal amount from each group, or are you going to be missing equal representation from all of those? If you really do care about particular groups and characteristics and you want to make sure they are represented in your sample, then what you would use is a stratified sample. So a stratified sample is where a population is divided into subgroups called strata, and a sample is randomly selected from each stratum. This is a way to make sure that your sample has representation of important characteristics, demographics of your population. So for example, if I'm designing a survey of business students, I want to make sure that I have people in my survey response that are first-year students, second-year students, third-year students, fourth-year students. So with stratified sampling, I would take all the first-year students and I would use simple random sampling. Of course, I bumped that, so now who knows where it went. Simple random sampling. So I'd use simple random sampling. I'd randomly choose some people from the first year list. I'd randomly choose some people from the second year's list. I'd randomly choose from the third year's list and the fourth year's list. With stratified sampling, we need to be able to show that so we have maybe some historical information, that there is a difference in opinions or characteristics with these different groups. So the reason that we're pulling them out and we're making sure they're represented in the sample is because we know there's differences in opinions between first years and third years. Or maybe there's differences based on whatever we're surveying, based on income level, or the gender identification, or maybe the city they're in. So we would look at, what are we trying to represent in the sample? Well, we need to have some kind of information or data that shows there is a statistically significant difference with those groups in order for us to prioritize that representation in the sample. Okay. If you're going to do stratified sampling, no more than 6 stratas, no more than 6 different groups. We talked about, a business degree, first, second, third, fourth year, that's 4 strata. When you start to get too many, then what you end up with is a very small number in each of your groups. And then you're not really able to capture whether or not the feelings of, let's say, the first year business students represents all the first year business students. So we want to make sure we have a significant sample size within each of the strata. So that's why you don't want to have too many of them. Your strata must be mutually exclusive and collectively exhaustive. So you're picking something to focus on and you need to have all the different categories there, and they can only fall into one category. So if we're looking at what year you are in the degree, if you're a first year, you're not a third year. If you're a third year, you're not a second year. And there are only 4 years, 1, 2, 3, and 4, right? So it is collectively exhaustive, all of the options, and mutually exclusive, you only fall into one of them. Okay. So stratified sampling, we use this where we want to make sure there's representation in our sample of key characteristics from our population. With stratified sampling, we want to look at what portion of the population falls into each of the stratums, and we want to then often make sure that that same proportion is represented. So if we were looking at our first years, and if we look at the breakdown of our program, and so let's say that 20% of our students are first years, because you can also leave after the first year or leave after the second year, or you can continue on for the 4, whether you want a certificate, diploma, or a degree. So if our first years are 20% of the population, then we want them to be 20% of the sample. So we would look at the size of the stratum compared to the size of the population so that we could have that same representation. So here it's not just about do we have first years and do we have second years, but do we have proportional allocation? Do we have that same percentage in the sample that we have in our population? Do they match? Okay. You could choose instead to have disproportional allocation. You could allocate more of the sample to a strata that has larger variability. So let's suppose that we think all 4th years essentially have the same opinions about our program. First years have a greater variety of different opinions and perspectives. And so we would say, okay, well, let's make the percent of the sample for 4th years be half of what they are as a percentage of the population, and let's make first years be double the percentage in the sample compared to what they are in the population. This would allow us to capture more of the variability in the responses from that particular group. But if our assumptions are wrong, that we're assuming there's less variability in the 4th year opinions and more variability in the first year opinions, then by forcing it to be different than what is representative in the population, we've added to the sampling error. Okay, this is called a double weighting scheme if you're doing this, because you're adding a weighting to a particular group to adjust for that difference in how much difference there is in their opinions. And so you're weighting not only on what percentage first years are in the population, but also you're changing that weighting so you can get at the more variability in their responses. So be very careful about disproportional allocation, that you are not adding additional error to it, that you have good historical data that would argue for making that change to the representation. Okay. When you select your strata, you then will select using a simple random sample, for example, from each of the strata. So you've chosen this characteristic, said it was important, and then from the group who has that characteristic, so of our 4-year degree, we've said being a first-year student is the key characteristic. We randomly select you from that group of first years. So that sample then will more accurately reflect the characteristics of the first years. And so what we've done is we've lowered that sampling error by using that simple random sample, but we've also made sure that we have the difference in terms of opinions and perspective based on these cohorts that are important. So you must know which characteristics are relevant and have some historical information that leads you to that. This is commonly used with political polling, right? We have key voting groups. So we would ask people who have historically voted conservative versus people who have historically voted more liberal, and we ask them their thoughts about the leadership. We have these characteristics that are important for predicting how people are going to feel. That might be geographic location. We want to make sure that If we're doing a nationwide poll of the Prime Minister, we not only want to make sure we have respondents from Alberta and Quebec, but we would want to weight them based on the percentage of people that live in Alberta versus the percentage who live in Quebec, or based on the percentage who vote in Alberta versus Quebec. So we want it to match that representation. So we see this a lot in political polling. We might also see not just their previous party affiliation or their geographic location, but you might also have age group. Because there has been historical data that shows a different, like younger populations tend to vote more liberal, and older populations tend to vote more conservative. So we tend to see these with political polling. We also tend to see it with media research. All right, so we have talked about stratified sampling. We've talked about our systematic sampling. We've talked about simple random sampling. So simple random sampler being the simplest, everyone has an equal chance of being involved. Systematic sampling, we're going from a list and we're picking every 10th person, every 20th person. So the idea here is that there is some kind of population list from which to pull from, and we're trying to expedite it compared to that simple random sample. Stratified sampling, we want there to be that equal likelihood of being selected, but from within a strata. So we are saying here's important demographics or characteristics of the population that we need to make sure are represented in the sample. And so then we can choose for them to represent that same percentage in the sample as they do in the population, or we can more heavily weight one group versus another. The last type of probability sample we want to talk about is that of cluster sampling. Cluster sampling is when we have a population that is divided into naturally occurring geographic or other boundaries. These boundaries must be mutually exclusive and collectively exhaustive. So what we do is we randomly select clusters, and then we randomly select people in those clusters. So we talked about political polling just a second ago and how stratified sampling would make sure that if we were doing political polls, we would have a sample that had the number of people from Quebec as a percentage of the sample match the percentage of people from Quebec in the greater Canadian population. So there we're representing that location, Quebec, to proportionally match in the sample and the population. With a cluster sample, we are going to divide up, let's say we'll take Canada, and we'll divide it into regions, maybe metropolitan statistical areas, MSAs. So this is cities and surrounding areas that are of a certain population size. And essentially what we're doing is kind of throwing in a hat all those different cities in Canada and randomly selecting some cities. And then once we randomly select a city, we would randomly select people within a city. So what we're doing is we're trying to make sure that we cover the vast geographical area that is in our population, but rather than looking at getting equal representation from each of those geographical locations, we're choosing the geography at random and then choosing from within that group at random. So we're assuming that these clusters are just as heterogeneous as the population. So as I said, we use a metropolitan statistical area, then we're saying, okay, well, here's these kind of population groups of about the same size, in terms of making sure that they have certain amenities. So if we're scattered across a large geographical area, then we would do that. So for example, let's suppose we wanted to study the household waste collection in the greater Red Deer area. So we want to look at household waste. What we would do is we would take all the different neighborhoods within Red Deer, and we would randomly select some neighborhoods, and then we would randomly select some people within those neighborhoods to participate in our study. Okay, so you have an equal likelihood of being selected in that geographical area, and then each geographical area has an equally likely chance of being selected. So we use this when we have large geographical spread to collect information, and it's just too cost prohibitive to collect information from every single geographic area. Otherwise, you're back to stratified sampling to say, okay, does our sample size represent how many people live in this neighborhood as a percentage versus that percentage for that neighborhood in terms of how they represent the greater population? Is that same representation in the sample? So we have talked about, find the list here, simple random sampling, cluster, stratified, and systematic. In our next video, we'll look at non-probability samples.